Selamat pagi semuanya. Good morning everyone. Hello Dr. Marzan.
Good morning, everyone. Hello, Dr.
Nice,
Nurul.
nice. Okay.
Am I audible?
Hello, hello. We will start shortly. Halo Pak Bibit, selamat pagi. Bisa dimulai ya Pak?
Siap, bisa. Silakan.
Oh ya, terima kasih banyak Pak Bibit. Pak Hakim bisa kita mulai ya Pak?
Oke, siap.
Oke. Oke, Alika mungkin bisa kita mulai.
Welcome to the International Webinar 2026 Series 2, everyone. You can scan the Zoom background on your screen. Assalamualaikum warahmatullahi wabarakatuh. Good morning, respected deans, head of department, honorable speakers, moderators, and participants. Welcome to the International Webinar 2026 Series 2, organized by the Faculty of Teacher Training and Education, Mula Warman University, in collaboration with University of Northern Philippines. My name is Alika Nazwa Maulida from the Physics Education Study Program, and I will be your Master of Ceremony for today. Before we begin, please ensure that your microphone is muted during the session. Let us start this program with enthusiasm and positive spirit. Please note that at the end of the session, we will display an attendance link. All participants are requested to fill out the attendance link. Today's agenda is, first, we will sing National Anthem of Indonesia and Philippines. Second is prayer. Third, a report and welcome speech. Fourth is documentation. Fifth is main agenda. And the last is closing. So now, we move to our first agenda. We will sing the Indonesian National Anthem, followed by the Philippines National Anthem. May I kindly ask all the audience to take your perfect position and turn on your camera. Thank you. Next, we will continue with the Philippines National Anthem.
Mga kababayan, ang pambansang awit ng Pilipinas. Kayang magiliw, kay masasinakalan, alam ng puso, sa higit mo'y buhay. Lupang hinirang, tuyan ka ng magiting, sa manlulupin, di ka pasisingil, sa gagatang tutok sa simoy at sa langit maubagaw, ay hinatang tulad, awit sa paglayang minamahal. Ang isang ng matawad mo'y tagumpay ka nag-iindig, ang bituin at araw niya kailan ang hindi magtitindig. Luman ang araw ng walhagit pagsinta, buhay langit sa piling mo. Ang hindi kaya ng pagkay mga amin, ang mamatay ng dahil sa'yo.
Thank you, everyone. To seek blessing for our webinar, we will begin with a prayer. The prayer will be led by Rizky Ramdhani Simatupang from Chemistry Education Study Program. To Rizky, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Let us take a moment to join together in prayer to the one true God, asking that our activity today be blessed and proceed smoothly. For those of the Islamic faith, I will lead the prayer and the other may follow along with your belief. Bismillahirrahmanirrahim. Allahumma sholli ala Muhammad wa ala ali Muhammad. Allah, you are the most merciful, you are the most compassionate, as we give thanks for your presence here today in an atmosphere of warmth and togetherness. May you bestow your blessing and approval upon this event we are holding. You are our Lord. This event holds great significance and meaning for us, especially in fostering bonds of friendship among fellow students and researchers. The finest of your creation. Allah, today we will be hosting an international webinar. Universitas Mula Warman collaborate with UNP. Therefore, bless all our step and action, and may this event be form of worship and a source of beneficial knowledge. Allah, you are the one and the universe. Through this event, we ask you to strengthen the unity and harmony among us through meaningful understanding. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Sallallahu ala Muhammad wa ala ali Muhammad walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Rizky. Now, we continue with the report from the Chair of International Webinar Committee, Dr. Abdul Hakim, MPD. To Dr. Abdul Hakim, MPD, the time is yours.
Oke. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good morning, everyone. Honorable Dean of Faculty of Teacher Training Education, Mula Warman University, represented by the Vice Dean for Student Affairs, Alumni and Partnership, Dr. Bibit Suhatmadi, Honorable Dean of the College of Teacher Education, University of Northern Philippines, Mr. Teresa Susan L. Manzano, Education Doctor, the speaker at this event, dear faculty members, our esteemed webinar participants. Praise and thanks be to God Allah Subhanahu wa Ta'ala. It is by His grace that we can gather in this spiritual space in good health to participate in this webinar. As the chair of the organizing committee, I would like to welcome and thank you all for your presence, as well as our fellow participants. This webinar is a collaboration between the Faculty of Teacher and Training Education, Mula Warman University, and the College of Teacher Education at the University of Northern Philippines. Another ongoing collaboration is the C-Teacher program. This program has been ongoing since 2023. This program is an exchange program between institutions in different countries. And we hope that this partnership will continue and grow in the future. Today's webinar aims to provide insight into the innovative approaches for teaching science, maths, and informatics. Therefore, we hope the participants can gain valuable insight and apply them in their respective field. And we would like to express our deepest gratitude to all those who have support this event, especially the Dean of Faculty of Teacher Training Education, Warman University, and the Dean of the Faculty of Teacher Training and Education at the University of Northern Philippines. The speakers who have kindly shared their knowledge, and our fellow committee members who have worked hard to prepare for this webinar. Finally, we apologize for any shortcoming in the organization of this webinar. I hope enjoy to the event. May it beneficial and contribute significantly to our development. I think that's all. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you, Dr. Abdul Hakim. We will now move to the welcoming speech. The first speech will be delivered by the Dean of the Faculty of Teacher Training and Education, Mullah Warman University, represented by the Vice Dean of Student, Alumni, and Collaboration Affairs, Dr. Bibit Suhatmadi, MPD. To Dr. Bibit Suhatmadi, MPD, the time is yours.
All right. Thank you, MC. The Honorable, the Dean of the Teacher of the College of Teacher Education of University of Northern Philippines, UNP, Dr. Teresa Susan L. Manzano, the Honorable, the PIC of C Teachers, Dr. Choi Nel Marzan, and the Honorable, the Vice Deans of Teacher Trainings and Education's Faculty of Mullah Warman University, Professor Muhammad Nur Hadi and Professor Azainil, the Honorable, the Head of the Mathematics and Exact Science Department, Dr. Hakim, and esteemed keynotes or invited speakers and moderators from UNMUL and UNP. Okay, I will mention one by one. Yeah. Okay, there is Risa May R. Ramboyan, speaker from UNP. Einstein James R. Martinez, speaker from UNP. Celine Aloy Shima Haris, speaker from UNMUL. Rukayah Nasution, speaker from UNMUL. Masita, speaker from UNMUL. And to the moderators, Janelle Joyce L. Dino from UNP, Atin Nuryadin, moderator from UNMUL, and Arum Sekar, moderator from UNMUL. Distinguished guests, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. May peace and God's mercies and blessing be upon you. And good morning. On behalf of the Dean of the Teacher Training and Education Faculty, Mullah Warman University, Professor Dr. Susilo, allow me to extend our warmest and heartfelt welcome to this to you all to this second series of international webinar powered by the Faculty of Teacher Training and Education, Mullah Warman University, in collaboration with the University of Northern Philippines. From here, Samarinda, one of the unique multicultural city in Indonesia. It is indeed an honor and privilege for me to have the opportunity to welcome you all to this international webinar in which experts and share their ideas and experiences. Mullah Warman University, via the Dean of Teacher Training and Education Faculty, is honored to have the privilege to be the host of this webinar, underlining innovative approaches for teaching science, math, and informatics as its themes. Therefore, I should convey my appreciation to the head of the organizing committee, Dr. Abdul Hakim, and the team for their efforts and hard work. Ladies and gentlemen, teacher training and education faculty has a strong commitment to facilitate its faculty members and students to pursue academic excellence. It can partially be achieved by networking, collaborations, cooperation, and partnership. By organizing this webinar, this international webinar, faculty members and students will pave the stepping stone to a strong national and international partnership and collaboration. As a result, they will contribute and improve their impact on the developments of science for a better society. Ladies and gentlemen, this international webinar will be successful only with the support of the invaluable speakers. Thank you, speakers, and the participants as well as the sponsors. Allow me to take this opportunity to express my sincere gratitude to all participants and sponsors and to all speakers. To conclude, I wish you all a successful deliberative discussions on this webinar. Ladies and gentlemen, before I close my speech, on behalf of the Dean of the Teacher Training and Education Faculty of Teacher Training and Education Faculty of Mula Panawan University, allow me to declare that this second series of international webinar powered by the Faculty of Teacher Training and Education, Mula Warman University, in collaboration with the University of Northern Philippines, is now officially opened. Thank you very much, and Assalamualaikum warahmatullahi wabarakatuh. Good morning.
Thank you, Dr. Bibit. The second welcome speech will be delivered by the Dean of the University of Northern Philippines, represented by the Program Chair of the Master of Science in Teaching Physics and Chemistry program, Dr. Joy Nel Marzan. To Dr. Marzan, the time is yours.
Good morning to each and everyone. I hope I am audible. Am I?
Yes, you are audible.
Okay. A pleasant day to all, most especially to Dr. Bibit, the Vice Dean of FKIP UNMUL, and of course to Dr. Nurul, our good friend and partner in numerous internationalization activities, not just in webinars, but also in C-Teacher, including research. So on behalf of our Dean, Dr. Maria Teresa Susan El Manzano, who is unable to be with us today due to another important commitment, it is my honor to convey her message and represent her in this gathering. So please let me read her welcome remarks. Respected administrators of the Faculty of Teacher Training and Education of the Mula Warman University, headed by Professor Dr. Susilo, distinguished speakers, faculty members, dear students, welcome to the International Webinar Series 2 with the theme Innovative Approaches for Teaching Science, Math, and Informatics. It is great pleasure and enthusiasm that we gather today for these meaningful academic engagements that brings together passionate educators and lifelong learners who share one common goal: to improve the quality of teaching and learning in a rapidly evolving world. Science, mathematics, and informatics are disciplines that shape how we understand the world, solve problems, and create innovations for the future. As educators, we are continuously challenged to make learning more engaging relevant, collaborative, and responsive to the needs of 21st century learners. This webinar series reminds us that teaching is never static. It evolves together with technology, research, and the changing realities of education. Today's gathering serves as an avenue for the exchange of ideas, experiences, best practices that can inspire us to rethink our pedagogical approaches and embrace innovation in our classrooms. Through the expertise of our speakers and active participation of everyone present, may we discover strategies that will empower our learners to become critical thinkers, problem solvers, and responsible global citizens. More importantly, this event highlights the value of international collaboration in education. Despite differences in culture, geography, and educational systems, we are united by our commitment to excellence and our passion for transformative teaching. To our esteemed speakers, thank you for generously sharing your knowledge and expertise. To all participants, thank you for taking time to be part of this academic endeavor. Your presence reflects your dedication to professional growth and educational advancement. As we begin this webinar series, may we keep an open mind, engage actively in discussion, and embrace new perspectives that can enrich our practices as educators and researchers. Once again, welcome to the International Webinar 2026 Series 2. May this event be fruitful, inspiring, and impactful to everyone. Thank you and have a wonderful day ahead.
Thank you, Dr. Maizan. Thank you for the inspiring speeches. We will now have documentation and group photo sessions. May I kindly ask all participants to turn on their cameras. Please smile and look at your camera. We will begin with the first slide. Second slide. Third slide. Fourth slide. Fifth slide. Sixth slide. Seventh slide. Eighth slide. Ninth slide. 10th slide. 11th. 12th. 13th. 14th. 15th. 16th. 17th. 18th. 19th. 20. And the last slide. Thank you, everyone. Now, we move to the main agenda with the theme Innovative Approaches for Teaching Science, Math, and Informatics. We will have two sessions with different topics. The first session from University of Northern Philippines and second session from Mulawarman University. From the University of Northern Philippines, the session title is Rethinking High School Chemistry Instruction, Innovative Strategies to Enhance Performance and Problem-Solving Skills. Now, I will introduce our moderator for today, Janelle Joyce I. Dinong. Janelle Joyce I. Dinong is a licensed professional teacher specializing in science education. She is currently pursuing a Master of Science in Teaching Chemistry at the University of Northern Philippines and serves as a special science teacher in the Senior High School Department of International High School. Her research interests include the integration of e-games in high school science instruction. I would like to invite our first moderator, Janelle Joyce Idinong from the University of Northern Philippines. To Janelle Joyce Idinong, the session is yours.
Thank you for the warm introduction. Good morning, everyone. I hope you are all feeling excited and ready for a session full of learning and inspiration. So welcome to our discussion on rethinking high school chemistry, innovative strategies to enhance performance and problem-solving skills. So today, we will hear from passionate young educators who will share creative and research-based strategies to make chemistry more engaging and meaningful for students. So a gentle reminder to everyone to please keep our microphones muted while our speakers are speaking to avoid any distractions. So let us all stay active, keep our minds open, and enjoy the session. So let's dive right in and begin with our first speaker. Our first speaker is Mr. Bobby C. Caballero. He holds a doctorate degree in educational leadership and management and is a licensed professional teacher specializing in science education. He is presently enrolled in the Master of Science in Teaching Chemistry at the University of Northern Philippines and serves as a master teacher at the Science Department of Narvacan National Central High School. His research interests include innovative practices in high school science instruction. So he will be presenting his study entitled Enhancing Grade 8 Students' Achievement in Atomic Structure and Attitudes Through Science Stations. So this sounds exciting. So without further ado, let us all welcome Mr. Caballero. Sir?
Okay, so thank you, Janelle, for that very warm introduction. To one and all, most especially to Dr. JN, Sir JN, and the rest, and all the participants, presenters. Good morning to one and all. Ay, ikaw na to. Mhm. Visible na ba, Janelle?
Yes,
Ma'am
sir.
Janelle, visible na? Audible ba ako?
Yes, sir.
Okay, so nakikita ba, Janelle? Visible na ba?
Yes, sir. Visible na po.
Okay. Okay, again, good morning, good day to everyone. So I am here to present an innovative pedagogical approach crafted to address resource limitations, and at the same time enhance scientific literacy within the realm of secondary education. My research entitled Enhancing Students' Achievement and Atomic Structure and Attitude Among Grade 8 Students Using Science Stations primarily examines the impact of science stations on the academic achievement and attitudes of grade 8 students in learning atomic structure. Again, I am Mr. Bobby Cabanero, a Master of Science in Teaching Chemistry student from the University of Northern Philippines. Okay, so to start my discussion, it is divided into 4 sections. First is the problem. The initiative of this study addresses a critical challenge in science education. The abstract nature of the atomic structure, as we all know, such as significant number of students in the Philippines struggle to visualize the subatomic particles due to their intangible nature. This often leads to disengagement and hinders academic performance, thus promoting rote memorization over genuine understanding. The problem also compounded by lack of physical laboratory sources. And moreover, the data gathered from our school during the school year 2025-2026, it indicates that atomic structure is one of the least mastered competency among grade 8 students at Narvacan National Central High School. So to address the problem, I will be presenting to you the solution. But before that, the traditional lecture-based training or learning in science education
Sir
often
Bobby,
results in limited student engagement. Hello, ma'am. Audible ba ako?
yung slide po, hindi po siya,
Ma'am? Hello?
yung slide Sir Bobby, hindi po siya
Nakikita,
nag-change.
ma'am?
Yes, sir. Sa
Ano
title
yung
lang po. Yung sa title lang po.
nag-change naman na sa akin dito. Hindi pa nag-appear, ma'am?
Hindi, sir.
Oh my, wait. Pero ano sa akin. Ano ba yun? Wait lang. Okay na, ma'am? Nasa
Yes,
slide 2 na ako, ma'am. Slide 2 na ako,
problem.
ma'am. Si
The
bar
problem.
problem and potential solution. Yan na, ma'am?
Yes, yes, sir.
Ah,
Thank you.
okay. Si bar problem tapos na. Okay. Ito na, ma'am. Potential solution. Nakikita na, ma'am?
Yes, sir.
Okay. So, to continue, sorry for that technical glitch. To continue, the traditional lecture-based learning in science education often results in limited student engagement. Another one for retention and underdeveloped critical skills. This study, the science station approach, robust pedagogical solution to transform classroom dynamic, inquiry-driven laboratories. And the core objective of this one is to shift learning environment from passive reception to active exploration and discovery. So this science station approach involves restructuring the classroom to facilitate active learning and inquiry. Complex topics are divided into smaller interactive stations, each designed to engage students with different facets of concept. And this method promotes also hands-on exploration, collaboration, and deeper understanding of scientific principles. A range of research studies substantiates the effectiveness of this science station approach, each highlighting significant benefits. We have De La Cruz and Ramos 2025 demonstrated improved students' retention of biology concepts, enhanced active learning, and increased collaboration. Another one, we have Garcia, Martinez, and Ruiz 2024, a systematic review indicating improvements in scientific and digital competencies, as well as enhanced inquiry and collaborative skills. We have also Hapstein and Luneta 2022 highlighted in their study that structured practical activities, both conceptual understanding, scientific reasoning, and motivation. We have also Mahmoud 2023 showed enhanced environmental literacy and scientific understanding among middle school students. Lastly, we have Santos and Villanueva 2024. They demonstrated improved science performance and higher engagement levels among grade 10 learners through a carousel learning strategy, a variation of the station approach. Further studies by De La Cruz and Ramos and Hap Harvey collectively indicate that science station approach enhances retention, conceptual understanding, and mindfulness. Also, research by Garcia and Luneta underscores the development of the crucial scientific and digital competencies, inquiry skills, scientific reasoning, and motivation. And moreover, the findings of Mahmoud and Santos emphasize that approach positive impact of the environmental literacy over overall scientific understanding, performance, and student engagement. Furthermore, these approach, okay, shift towards science station reconfigures the traditional classroom environment, transitioning from passive lecture setting to a dynamic inquiry-driven laboratory by addressing diverse range of learning preferences by our students, like visual learners, we have the analytical learners, collaborative learners, and we have the kinesthetic learners. The study also established five primary objectives. First, evaluate to evaluate the variance between the baseline outcome measurements in the calculation of subatomic particles. Number two, this is to ascertain the academic influence of the study. Number three, to quantify changes in the attitude among the students, the graded students. And number four, to assess the importance of the observed attitude shifts. And lastly, to investigate the relationship between academic achievement and the attitude changes among students. So, methodology. First, we have the research design. This study employs a one-group pretest post-test design, which is a common quasi-experimental design used to assess the impact of the intervention, of an intervention. This involves first a pretest, which was conducted before the intervention. This is to establish a baseline measure of participants' knowledge, skills, attitudes related to the objectives. The next one is the implementation of the science approach, which is the core treatment of the instructional strategy, which is being evaluated in this study. We have also the post-test evaluation. This is the final assessment, which was administered after the intervention. This is to measure the changes or improvements compared to the pre-test results. So the flow chart in the presentation clearly illustrates the sequence. So we have the pre-test, the intervention, and we have the post-test. The arrows also indicates a feedback loop from post-test evaluation back to the site station. And the pre-test diagnostic This suggests an interactive and refining process, perhaps simply emphasizing the cycle nature of the evaluation to improve the educational outcome. Further, the methodology, it is also specifies the type of sampling used, which is the purposive sampling. It is a non-probability sampling technique indicates that the participants were selected based on their characteristics criteria relevant to the research questions. This approach also selected the researchers who want to focus on a particular group only, which certain traits pertinent to the study. For the population, the study um involved the grade 8 science, grade 8 Darwin at the Narvacan National Central High School during the school year 2025-2026, with a total participants of 40 students, 11 of which are male and 21 of which are female. Okay, so we have the analysis. So here presents the utilization of the valid and reliable instrument use or paramount, guaranteeing that the study accurately measures its intended precision. So these instruments would, the absence of these instruments, I suppose, will compromise the credibility of the study findings. Okay, first one, we have the content validity. So the content validity uses the icons be yielding a value of 0.997. The research instrument used is a 20-item multiple choice exam, and it is designed to assess the students' comprehension on the atomic concepts. So to ensure the rigorous content, the validity, and the reliability of the instrument, the tool underwent validation by three DepEd master teachers who are experts in this endeavor chemistry. Their expertise, these expert evaluates and confirm that the items comprehensively and accurately represents the content domain, aligning to the curriculum standards and learning objectives. The results of the ICANS-V value denotes, okay, also that it is exceptionally high degree on the content validity, approaching to perfection. So this indicates only that there is a strong consensus among experts that the items are highly relevant, appropriate, and essential for the measuring intended for the content. For the reliability also of the attitude tool was also assessed using the Kerr-Richardson formula 20, resulting in a value of 0.955. The attitude comprises of 14 items, 5-point Likert scale questionnaire designed to capture um, the students' attitudes towards science, engagement with the learning approach. So the result signifies also exceptional consistency, reliability, while particularly well suited for the test for dichotomous item. It is also applicable to the Likert scales. The high value obtained for both of the validity and the reliability means only provides a compelling evidence for the robust quality of the research instrument. Okay. So the next slide also present to us the procedures conducted during the study. So we have three phases. So we have the phase one. This is the procedural flow, which is structured into three phases. We have the pre-intervention. So this one, this phase, this is to establish a baseline and prepare all the necessary materials for the study. So here, there is a custom development of the Atom Explorer Kit, which is the core of the activity. And the kit was meticulously designed by yours truly, the researcher, to align with also with the Matatag curriculum. So this is to ensure that there is a direct relevance to educational standards and objectives. So the customization of these instrument intervention and contextualization um, leads to the appropriateness and effectiveness of the material. Following the development of the kit was the diagnostic test. Okay, where it is administered to assess the participants' prior knowledge on the science concepts being tested. The second phase is the implementation of the intervention, which is the science stations approach. Um, the execution of this approach was done daily in a fast paced small group science rotations wherein the students who participated in the study engaged in a daily fast-paced rotation through various science stations. So it is a small group format wherein it encouraged them to collaboratively work and actively learn from the topic. This also promotes engagement. So this space also puts the theoretical framework of the science stations into practice. So in every station here, it is designed to provide hands-on inquiry-based learning experiences, enable the students to actively explore concepts. And at the same time, through these stations, they were able to expose comprehensively range of topics and skills within the Atomic Explorer Kit framework. And last phase is the post-intervention. This phase is the purpose of this one is to evaluate the effects of the implemented intervention, which is the science station approach. This is also to measure the learning gains parallel to the post-achievement tests were administered. So these tests are equivalent to the difficulty or the scope to the base diagnostic test, but use different items. So there is a parallel to mitigate practice effects, ensuring reliable comparison on the academic performance. For the attitude administration of the attitude test, the post-attitude Likert survey tests were also administered. This is to capture shifts the students' attitudes towards science and their engagement, comparing the results from the pre-intervention. So these three phases design ensures a systematic, comprehensive evaluation of the intervention, which is a science station approach. Okay, so this is the mechanics of the science rotation as you can see on the slides. So the intervention offers a practical framework as you can see by fostering active, engaging, and effective learning environment. So this slide focuses into the scientific approach or mechanic approach using the intervention. So building upon the foundation principles of the intervention, so this one further explains how the intervention was conducted. It is structured into three key elements. We have the grouping time, the anchor, and the design promote the timing, and the third one is the mabasa, anchor. So for the first one, grouping. So the primary mechanic for the grouping involves I divided them into 5 to 6 groups, collaborative groups. It is a small group structured to essential fostering peer interaction, stimulating discussions, and promoting shared problem solving, all of which are the fundamental to constructivist learning principles. These collaborative groups navigate through a series of distinct physical stations. So you can see there, each Station presents a unique learning activity or task directly related to the concept, ensuring a multifaceted approach to content mastery. The timing also, as you can see there, the timing I gave them 8 to 10 minutes per station. So this relatively short duration create a fast-paced, highly engaging learning environment. So the rapid transition between stations prevents stagnation and disengagement. So thereby keeping students to become actively involved and focused during the activity. This also encourages them to efficient task completion rather, and maintain sense of novelty. Next one is the enhancing concept understanding through tangible resources. So here, I am referring to the learning resources utilized during the activity, the Explorer kit that I did mention a while back. So this kit serves as the physical representation of making the abstract a scientific concept concrete and accessible to the student. So this one replaces, I suppose, the abstract lecture concepts with tangible manipulatives. Especially it employs the beads that I use, which colored beads represents the atomic components, the orbital shell also. Maps which I provided to them for visualizing electron configuration. This hands-on approach allows students to physically deconstruct, and interact with models of the atomic structure. So, by translating the abstract into a concrete tactile experience using the kit facilitates deeper conceptual understanding, enhances retention, and caters to various learning styles. The circular diagram here, okay, represents the entire active rotation. So as you can see, we have 5 stations rather there. Represents the distinct rotation, groups engaged were in with the Explorer kit. So the arrows illustrate the sequential movement from first station down to the last station. So this one is a diagram, the circular one. Okay, so this is how the kit looks like, most especially the element card. Here is the actual picture of the element card that I used during the experimentation. We have also here the map wherein this was used for them to build and to construct and deconstruct the atomic structure. So these are the components of the kit. Uh, we have the beads also, which represents the different parts of the atoms. We have the neutron, the electron, and the proton. So I use colored beads because I believe that using beads will give them a distinct appearance, physical forms wherein student can physically visualize and physically uh, determine the different elements of the atomic structure. We have also the mapping structure, the wor- the sign to the structure, the electron shells here, this one, the second picture one. And then we have also the element card, which is one part of the kit. The element card provides numerical information about a certain elements. Okay, example, the carbon element. We have also here the atomic number, the mass number, etc. Okay, so this one, students use this one to determine the number of protons, the electrons, and use this one for them to be able to calculate the number of neutrons using the mass number and integrating arithmetic or mathematical computations in the process. So this tangible material is, I believe, is a true innovation that lies on the engagement, okay, facilitated by the kit. So physically mapping the different structure of the atoms allows them to give a deeper understanding on the concepts. So So what is the importance of this one? So the KIT, okay, directly address the challenge of teaching abstract atomic concepts by promoting learning, strengthening problem-solving skills, and providing multi-sensory approaches among our students. So these engagements expected to lead them into a deeper comprehension, retention, and at the same time, key objectives for the science, the study itself. Okay, so these are the different stations wherein the students underwent during the investigation or the study. So the first one is the station one is the proton powerhouse. So this is the element card used. We have also here the activity sheets wherein I develop also the activity sheets, which is aligned with the objectives of the study. So the first station, the proton powerhouse, centers on understanding on the atomic number of the elements and the rule of the protons. So using the element carbon as our example. So the activity involves physically placing the red proton or the beads in the nucleus space, either in the workspace for the atomic number. So yan yung gagawin nila. So the station firmly establishes the atomic number, defines the element, and represents the number of protons, determine the element's identity and the positive charge in the nucleus. Station 2 here focuses on the neutron nucleus, focuses on the oxygen. So here I use oxygen as the example. So neutron nucleus students involved into the concept of mass number and the role of neutrons here. So in this activity, students are guided to compute the mass number of a given element. So the learning outcome on this station is that it reinforces the composition of the nucleus and introduces concepts of isotopes, and makes the abstract calculation of neutron concrete also on station number 2. While in station number 3, the electron orbiters, sodium as the example element, here it addresses the distribution of electrons and the concept of a neutral atom. On this station, students understand the balance of neutral atom given the element sodium as my example during the activity. Here, this station teaches the students about electron configuration, the concept of electron shells, and how the number of electrons balances the number of protons in a neutral atom. So this physical placement tokens provides visual kinesthetic understanding electrons occupy a different energy levels here. So the journey ensures that the students gain a fundamental understanding of the subatomic principles. We have also the station number 4 here, the aluminum construction. This is in station 4, here it represents a comprehensive synthesis exercises wherein students understand proton, neutron, and electron, wherein they will going to integrate a discrete concepts to construct holistic atomic model. Here in this activity, the objective of this activity is to comprehensively evaluate the students' understanding, successful completion of the necessary application of the knowledge related to atomic number, mass number also, and the electron shell. So this is an independent construction, promotes more profound understanding of the atomic structure. And last but not the least is the fifth station, the element investigator. Here, it transitioned from physical modeling to mathematical and analytical reasoning. So it gives emphasis thorough on the documentation and the investigative of the various elements of the study. So here, students were provided with element cards, of course, which is the chlorine and the iron. So their task is to transition away from physical models and engage them in a mathematical computation involving number of protons, neutrons, electrons, and subsequently meticulously document them using the activity sheets. So here is the actual activity sheets and actual material used during the study. So this session designed to enhance the analytical proficiencies among students, reinforcing quantitative dimensions through systematic calculations and recording. So, furthermore, it serves to promote scientific communication and data organizations among them, bridging the gap for practical application and formal scientific reporting. So, yan yung mga stations conducted during the process. And here, the next slide
Thank you,
is
Sir
the...
Bobby.
Ma'am,
15 minutes po. 15 minutes.
kayo
Thank
man,
you.
ma'am? Kayo man, ma'am? Fine na ba ako, Ma'am Janelle? Okay, so here is the statistical tool used during the study. Okay? So yan, nasa slide. So I will not thoroughly discuss it anymore. Okay, so we have also the results, which is the most important. Okay, this is the result of the study. So as we can see here, the bar chart, which is on the left one, clearly demonstrate an increase in the academic performance of the student from the pre-test to the post-test using the intervention science station. Which means that this improvement is not only numerically evident but scientifically significant. This is also to confirm that the observed academic growth is statistically significant. Further, also, it reinforces a positive outcome on the mastery improvement among the students. So the number of students in the highest mastery category increased by 3 in the pre-test, 12 in the post-test. So the attitude here, the next chart, the scatter plot here represents the perspective, okay, illustrating the relationship between the students' post-achievement and post-attitude scores. So evidently, our relational analysis using the Spearman rank correlation revealed weak, unfortunately, a weak significant correlation indicates no statistically significant relationship between the higher academics. So maybe these findings highlights academic mastery does not automatically translate into a greater affinity for the subject. While intervention significantly boosted students' performance and knowledge, however, it did not result statistically significant improve their overall scientific attitudes. This implies that science stations effectively drive significant academic growth and understanding about the concepts of atomic particles. Ayan. And reflection, which is my last slide. Okay, so these are my reflections. First, it gave me the opportunity, my reflection undergoing the CBAR process. First one is it gave me the opportunity to reflect deeply on my teaching practices and identify strategies that directly respond to learners' needs. Through this journey, I learned that research is not only an academic task, but also a practical tool for improving classroom instruction. One of the most meaningful experience was implementing an intervention like the science station approach and seeing an impact of the students' learning. It reinforced the importance of using innovative learner-centered approach to address gaps understanding. So the stages of planning, action, observation, reflection work well in guiding the study and ensuring evidence-based decision. What are the challenges? At the same time, the process came with a challenges such as managing time since I am handling 5 sections, organizing data due to some teacher tasks, and adapting the unexpected classroom situations. These difficulties required flexibility, perseverance, but they also strengthened me as a researcher and a student. One. Then, lastly, the CBAR process enhanced my understanding of the reflective teaching and evidence-based practice. Likewise, it helped me grow not only as an educator or teacher, but also as a researcher, committed to continuous improvement and meaningful change in the classroom setting. So that would be all. So that ends my presentation. Thank you for listening. I hope you learned something from my simple research. Again, mabuhay po tayong lahat and good morning again to one and all. Thank you, Ma'am Janelle.
Thank you so much, Sir Bobby, for that insightful and engaging presentation. So a quick reminder to our presenters, you are given 15 minutes only to present. And for everyone, our 10 minutes Q&A session will take place after all the three speakers have shared their talks. So feel free to jot down your questions and we'll be excited to hear from you later on. Okay, so now let's move on to our second speaker. Okay, Miss Risa May R. Ramboyan. Okay, Miss Risa Ramboyan is a graduating student, magna cum laude, in the Bachelor of Secondary Education, major in Science program at the University of Northern Philippines. She completed her international internship at Lampang Rajabat University and her local internship at Ilocos Sur National High School. Her research interests focus on innovative approaches in chemistry education, particularly phenomenon-based learning. So she will be sharing to us her study entitled Effects of Phenomenon-Based Learning on Grade 11 Students' Performance in Chemical Reactions. So let's give her a warm welcome. Ma'am, are you ready, Ma'am Risa? Ma'am Risa?
Yes, ma'am.
Okay.
Visible na po, ma'am?
Yes, ma'am.
Okay. Good day, everyone. Faculty members, fellow researchers, students, and participants from different institutions. A pleasant greeting to all. Salamat pagi. I am Risa May Ramboyan, a graduating student from the Bachelor of Secondary Education, major in Science at the University of Northern Philippines. And it is an honor and privilege to present my research study or classroom-based action research with the title Phenomenon-Based Learning Effects on 11th Grade Learners' Performance in Chemical Reactions. So this is the outline of my presentation, starting with the CBAR problem and potential solutions. So to give you a brief background of my study, I will be presenting the problem being addressed in this study and the potential solution to this or to such problems. So the main problem lies on the low performance of students across various countries, as reflected by international assessments such as PISA or the Program for International Student Assessment, and which shows that the students had a significant percentage of students across various countries that performed below the proficiency level in science. And when it comes to the Philippines context, the Filipinos also exhibit low performance in science education, as reflected also in the same assessment. And also in other assessments, such as the TEAMS or the trends in international mathematics and science study, the Philippines or the Filipinos also placed at the bottom of the ranking. And for the local context, at the University of Northern Philippines Laboratory School, I observed that learners struggle with deep understanding in chemistry, so particularly in the subject chemistry. So students can perform experiments and follow procedures, but they struggle to explain concepts and analyze results and apply it to other contexts. So, and to this, chemistry is then perceived as a hard subject, which leads to decrease in interest, leading to low performance in this subject. So with these problems, it highlights the need for a new and effective instructional approach that will engage learners and make them have a deeper understanding of the topic, especially in chemistry. And one of this approach is the phenomenon-based learning or the PHBL. So in this PHBL, learning begins with real-world phenomena. So the key features of this PHBL, it includes the grounded in direct observation. So with this PHBL, the students are given the chance to conduct hands-on experiments, minds-on experiments. So it helps with this, the development of higher order thinking skills, which is usually being used in chemistry, is being developed. And another quality or feature of the PHBL is that it promotes collaboration among learners. And with that, this study aimed to determine the effects of phenomenon-based learning and chemical reactions for grade 11 learners at the University of Northern Philippines Laboratory Schools for the school year 2025-2026. Specifically, it sought answers to the following questions. First, what is the level of performance grade 11 learners before and after their exposure to the phenomenon-based learning in chemical reactions? Is there a significant difference between the level of performance in grade 11 learners before and after their exposure to HCl and chemical reactions? And lastly, based learning on their performance in chemistry study. And with the research design, so this is design integrating both quantitatively. For the quantitative analysis study was the one group pretest post-test research design, wherein the same group of participants were assessed before and after the intervention. And for the qualitative phase or qualitative aspect of this study, the specific research design used was the basic qualitative research design. And this process involved the collection of qualitative data within an evolving set of questions and procedure, followed by inductive analysis. So it developed themes from specific to general patterns, with the researcher interpreting the meaning of those data. So as for the populations, the quantitative phase of the study involved 30 grade 11 learners from section Descartes of the senior high school program at the UNPLS during the second quarter of academic year 2025-2026. And for the qualitative phase, it involved a total of 8 learners who were selected from the same group of participants. And for the research instrument, starting with the quantitative phase or quantitative aspect of this study, it utilized an achievement test in chemical reaction. So the researcher developed a 50-item achievement test with or alongside with a 50-item parallel test. And the development of this instrument was aligned with one of the learning competencies of the K-12 curriculum under the topic chemical reactions, specifically describe the evidences that a chemical reaction has occurred. And to ensure the validity of this instrument, it was evaluated by 3 expert chemistry educators. And as we can see here, that the mean rating was 4.67 with the descriptive interpretation of very satisfactory. Also, it was subjected to ICANN's validity and the computed value was 0.92 with the descriptive interpretation of excellent validity. So this implies that there is a high level of agreement within or among the expert validators, which ensures that there is a strong content validity of the instrument. And then afterwards, it was subjected to pilot testing, and then the reliability was established by calculating its reliability using the KR20 formula or the Kuder-Richardson formula 20. And it yielded a value of 0.80 for the pretest, while 0.81 for the post-test, which both instrument resulted to good reliability. So for this instrument, it answered the research question number 1. Okay, next. For the qualitative phase of the study, it utilized an interview, and for this interview, the researcher adopted the semi-structured interview guide from the study of Perez and Tabunan. So it was modified according to the objective of this study. So as we can see here, the sample interview guide for the qualitative data, and if you want to see the document, you can just scan this QR code. And for this, the learners who were interviewed were purposefully selected based on the quantitative results. So the quantitative results were first analyzed before the conduct of the qualitative phase. So those with high N-gain score and medium N-gain score or the normalized gain score were chosen or considered to be the participant of this qualitative phase of the study. So the data gathered on this instrument answered the research question number 3, the qualitative research question. Now let's move on to the data gathering procedure, which was divided into 3 phases, starting with the pre-intervention phase. So in this pre-intervention phase, it starts with instructional planning, which includes the development of the lesson plans, phenomenon-based learning kits, and the instruments. And then after that, communication letters were then prepared to seek approvals to the principals, validators, parents, and students to ensure the ethical conduct of this study. And lastly, for the pre-intervention is the administration of the pretest, the 20-item chemical reaction test for grade 11. And for the intervention phase, this is now the learning intervention, the phenomenon-based learning. So it was anchored on the segments of the PHBL by Troth and Mulvena of 2022. So there were total of 7 segments, which will be discussed later on individually. And to facilitate the implementation of this phenomenon-based learning, the researcher developed a total of 4 phenomenon-based learning kit anchored on the same learning competency. So on the PHBLK1, it focuses on the topic on the evidence of chemical reaction, which is the change in color. For the PHBL2, the formation of precipitate. For PHBLK3, the formation of gas, and lastly, the change in temperature. So these learning kits were used as a guide to facilitate the implementation of the intervention. Okay, now let's go back to the learning segments of the PHBL, starting with the introducing the phenomenon. So the first stage introduces the learners with the phenomena using varied formats such as videos, presentations, experiments, demonstrations, and short comics. And then followed by the formulating question segments, wherein the students were given driving questions board and observe, wonder, predict cards as activity tools. So in this stage, the student share their initial ideas, questions, or whatever observations about the phenomenon that they just watched or observed on the first segment. And for the third segment is the developing an initial model. So in here, the prior knowledge of the students about the phenomenon were assessed using phenomenon mapping charts. And then the students investigated the phenomenon using hands-on experiments related to the phenomenon. So they collected and recorded data systematically using observations and data tables. And next, the data gathered on the last segments were then processed and analyzed for them to understand the phenomenon. So they drew conclusions through guided analysis and activity sheet questions. And then after processing the phenomenon, they are now going to develop or revise their initial model using the gathered evidence and class discussions. There will be also reflections, or there were also reflections in this part for them to know whether which part of their answer in the initial observation were right and which part is wrong. And lastly, an evaluation was then administered to assess learners' individual understanding using evaluation cards. And now for the last phase, the post-intervention. It started with the administration of the post-test, followed by the analysis of qualitative data, and then the qualitative or the implementation of the qualitative measures, and the analysis of qualitative data, followed by the integration. So we will discuss this later on. So it's here, the data analysis. So the pre-intervention and post-intervention test scores were assessed for normality using the Shapiro-Wilk test to determine the appropriate statistical test for analysis. So as we can see on table 1, the Shapiro-Wilk test results indicated that the pre-test scores did not significantly deviate from normality, since the p-value of the pre-intervention test scores and the post-intervention test scores were greater than the set significant level of 0.05, which implied that the data was normally distributed. And then here we have the tool for analysis of the quantitative data. We have the mean, frequency, and percentage, which assess the level of understanding or performance of the students in chemical reactions before and after the intervention. And then based on the Shapiro-Wilk test results, it was deemed appropriate that paired sample t-test was the appropriate statistical tool in analyzing the data to know whether the data or the pre-intervention and post-intervention test scores have significant difference. And then we also have the analysis framework for the qualitative data. So the learner interview responses were analyzed using reflexive thematic analysis, which is an approach that generates themes to explain people's experiences, perceptions, views, and representation of a given topic. So the researcher closely examined the data and identify the patterns and common themes. So the generation of themes is the last part of the reflexive thematic analysis, which led to the understanding the influence of the phenomenon-based learning to the learner's performance in chemical reaction. And now let us move on to the highlight of this presentation, which is the result or the discussion of the results. Starting with the quantitative result. So we have here the frequencies of the pre-intervention and post-intervention test scores. And as we can see on the pre-intervention test scores, right here on the left side, majority of the learners scores fell under the satisfactory level, followed by the outstanding, and then followed by fairly satisfactory. Yes. And then for the post-intervention test scores, we can see that majority of the learners' test scores fell under outstanding, followed by very satisfactory, and very few students' test scores under satisfactory. So this implies that there is an improvement in the learner's test score before and after the intervention. And also another one, this is the means of the pre-intervention and post-intervention test scores. We can also see that before the intervention, the mean rating of the scores of the students is 59.5 80% with a descriptive rating of satisfactory. Whereas after the intervention, the learners had a mean rating of 81.17%, which reached the optimum level of outstanding, the outstanding level. So therefore, this implies that the performance of students after the intervention was higher compared before the intervention. And now for the test for the significant difference between learners' performance before and after their exposure to phenomenon-based learning, we can see on table 2 the t-test result for the pre-intervention and post-intervention test scores.
Muted ka, Ma'am Risa. Nakamute ka, Ma'am.
Okay. Nag-stopan na, Ma'am.
Yan po.
Okay. So for the computed p-value was less than the set level of significance of 0.05, which implies that there is a significant difference between the pre-test and post-test scores of the students, with the post-test having the higher mean because the pre-test only has 11.90 mean while the post-test have 16.23 means. Therefore, the null hypothesis was then rejected because there is a significant difference between the test scores before and after the intervention. And now let's move on to the qualitative results of this study. So here, the table 3 presents the influences of phenomenon-based learning on grade 11 learners. Based on the analysis of the transcribed interviews using the repertory grid, which is right here on the QR code on the lower right corner, you can just scan it. It will lead you to the repertory guide. 3 common themes have emerged. So the first one is PHBL allows learners to develop positive attitude towards science. So the development of favorable attitudes towards science was manifested to a total of 9 significant statements, and it is developed mainly through the investigating the phenomenon segment of the PHBL. So the students mentioned that the engaging and enjoyable experiment and the challenging activities made them more interested to the topic or to science in general. And for the theme 2, PHBL enhanced conceptual understanding in chemistry. So PHBL allows learners to have a deeper and clearer concept grasp as manifested on the 9 significant statement based on the learner interview as well. And for the last theme emerged was the PHBL strengthened teamwork and collaboration. So PHBL allows a student to develop their collaborative skill building, which was emerged from the 5 significant statements, also from the same learner interview. So the students were able to work collectively, share their ideas, and discuss observations. Since, as I've said earlier, that one of the features of PHBL is that it promotes collaboration among learners. And now, these quantitative and qualitative results were then integrated using a joint display analysis. So, on table 4, wow, we have here the joint display of the quantitative and qualitative results. So, for the quantitative results, the pre-test and post-test scores of the learners improved from satisfactory to outstanding, indicating an increase in learners' performance after the intervention. And also, there is a significant difference between the pre-test and post-test scores of the learners before and after their exposure to PHBL, with the post-test having a higher mean. So this answered the research question, 1 and 2. And for the qualitative results, the emergence of the three teams as mentioned earlier, which collectively enhances or facilitated the improvement of the performance of grade 11 learners in chemical reaction. So this was the meta inference. The phenomenon-based learning is effective in improving the performance of grade 11 learners in chemical reactions. And it was supported by the study of these researchers. And that concludes my research study. And to share, beyond the findings of my study, this research also become a meaningful learning experience for me as a future educator conducting this classroom-based action research. And with that, I want to share my reflection throughout this journey. So to keep it short, conducting this CBAR or classroom-based action research made me realize that science education is more than teaching formulas, concepts, and laboratory procedures. As I conducted my study on PHBL or the phenomenon-based learning in teaching chemical reactions or chemistry, I saw how learners often struggle to truly understand chemistry when lessons are taught in purely abstract manner or in convention or traditional manner, I should say. So this experience opened my eyes to the reality that many students can follow instructions and memorize information, yet still find it difficult to explain concepts, connect ideas, and apply their learning to real life situations. And because of this, I became more aware of the importance of making science meaningful, relatable, and engaging for learners. So I hope that you can adopt this learning intervention on your future instructions. And I hope also that this phenomenon based learning will not just end inside the classroom because it has a higher or greater potential. It can be beyond, it can also solve problems, real world problems. And that's it for my presentation. Again, I am Risa Miramboyan from the Philippines. Terima kasih.
Okay, thank you so much, Ms. Ramboyan, for that wonderful presentation and for highlighting innovative teaching strategies. So again, questions will be entertained later after our last presenter. And now for our third speaker, we have Mr. Einstein James R. Martinez. Mr. Martinez is also a graduating student, magna cum laude, in the Bachelor of Secondary Education major in Science program at the University of Northern Philippines. He completed his international internship at Chiang Rai Rajabat University and his local internship at Lusok National High School. So his research interests focus on innovative approaches in chemistry education, particularly problem-based learning. So he will be presenting his study to us entitled Problem-Based Learning, Effects on Grade 9 Students' Problem-Solving Skills in Ionic and Covalent Compounds. So let us all welcome Mr. Einstein James R. Martinez. Sir? Sir Einstein, are you ready, sir?
And my classroom-based action research entitled Problem-Based Learning, PBL, Effects on Ninth Grade Learners' Problem-Solving Skills in Ionic and Covalent Compounds. And with that, let us now proceed to the introduction and discuss the educational problem addressed by this study. All right. So science education in the Philippines continues to face serious challenges, especially in developing learners' scientific literacy and problem-solving skills. So there is scientific literacy crisis, and students have poor problem-solving mastery. International assessments such as PISA and TIMSS revealed that many Filipino learners struggle in science, particularly in applying concepts to real-life situations. And one major reason behind this is the continued use of traditional teaching methods, where students often become passive recipients of information instead of active participants in learning. In chemistry, this becomes more evident because concepts such as ionic and covalent compounds are abstract and difficult for students to connect to everyday experiences. And as observed during classroom interactions, many learners struggle to analyze problems, plan solutions, and explain scientific reasoning systematically. Because of this, there is a need for a more active and student-centered approach to learning. Thus, this led to the use of problem-based learning. Now, PBL is an approach where students learn through solving authentic real-world problems. Instead of memorizing concepts, learners investigate situations. They collaborate with their classmates and they apply scientific knowledge in meaningful contexts. This study specifically used the Arendt's PBL framework, which includes 5 phases: problem orientation, organizing students, guiding group investigations, developing and presenting results, and analyzing and evaluating the problem-solving process. Through these phases, learners actively engage in solving problems while developing their problem-solving skills. All right, now that the educational problem and the proposed solution have been established, let us now look at the specific objectives that guided this study. So this study aimed to determine the effect of problem-based learning on the problem-solving skills of grade 9 learners in ionic and covalent compounds. Specifically, the study sought to determine the learner's level of problem-solving skills before exposure to PBL, their level after exposure to PBL, and whether there was a significant difference between the pretest and post-test results. And the skills measured were understanding the problem, planning problem solving, implementing the problem solving plan, rechecking the solution, and overall problem solving performance. And then after identifying the objectives of the study, let us now proceed to the methodology used to answer these research questions. So the study utilized a one-group pretest post-test design, and the participants were 34 grade 9 learners from Gregorio del Pilar, University of Northern Philippines laboratory schools during the school year 2025-2026. Philippines laboratory schools during the school year 2025-2026. Instrument problem-solving skills test. The study adopted 4 problem scenarios from the instrument for assessing problem-solving skills in chemistry developed by Valdez and Bungihan 2019. And the instrument contained 4 problem scenarios, with each scenario measuring one specific problem-solving skill. And to ensure validity, the test instruments were evaluated by 5 master teachers in science and were found to have very high validity. Here are samples of the research instruments. And as you can see, the test 1 only covers the understanding the problem skill. As I said earlier, that each test or each problem scenario only covers one specific or a specific problem-solving skill. And then before implementing the intervention itself, several preparatory steps were first conducted, which are included in the pre-intervention phase. So first, the researcher constructed the pre-test and post-test instruments. Followed by the adapted and constructed research instruments were validated by 5 science master constructed research instruments were validated by 5 science master teachers. And then PBL lesson plans and learning kits were developed based on the grade 9 competency to recognize different types of compounds based on properties such as melting point, polarity, and electrical conductivity. So the green one here is based on algal bloom for the property electrical conductivity. The orange one is anchored on asphalt road melting, which is for melting point, and then for the blue one, it was anchored on oil spill, and that is for the polarity. Next, communication letters and consent forms were also prepared and distributed. And lastly, the pretest was administered to determine the learner's initial level of mastery of problem-solving skills. Alright, after completing the necessary preparations and gathering the baseline data, the intervention phase was then implemented using the problem model. Alright, the intervention followed 5 phases of RN's framework. First, problem orientation, where students were introduced to a real-world problem through a video presentation, and this video motivated learners and encouraged them to identify the scientific issue involved. So here are pictures during the problem orientation. So here are pictures during the problem orientation phase. Then the next phase is the organizing students. Learners were grouped heterogeneously and tasked to analyze the problem, identify known and missing information, and plan possible solutions. Alright. This is the guided group investigations, where students conducted experiments, gathered data, and processed observations related to ionic and covalent compounds. Fourth, developing and presenting results, where the groups presented their findings to class and participated in peer assessment and discussion. And lastly, analyzing and evaluating the problem-solving process, where students reflected on their learning experience and evaluated their solutions, as well as they also identified areas for improvement. Right? Now, following the intervention phase was the post-intervention phase, where following the intervention phase was the post-intervention phase, where post-test was administered and the analysis of data was conducted. Alright, so that's for the methodology. Now let us examine the findings of the study and determine whether problem-based learning improved the learner's problem-solving skills. Alright, so here's the learner's problem-solving skills before and after their exposure to the problem-based learning. And the results showed clear improvement in learners' PSS after exposure to PBL. So during the pretest, most learners were only at the average and closely approximating mastery levels. However, during the post-test, more learners moved toward closely approximating and mastered levels. There was also a noticeable decrease in the number of learners under the low and very low mastery levels. So this suggests that PBL helped learners develop deeper understanding and stronger problem-solving abilities. And to further support these findings, let us now examine the learner's mean and median scores before and after the intervention. So the results revealed that all post-test mean scores were significantly higher than the pre-test scores. The pre-test mean percentages ranged from scores were significantly higher than the pre-test scores. The pre-test mean percentages ranged from approximately 53 to 62%, while the post-test means increased to around 75 to 79%. Similarly, the overall median score improved from 9.5 here in the pretest to 12.5 in the post-test. These consistent increases across all indicators suggest that the intervention effectively improved learners' problem-solving skills. So while the increase in scores already suggests improvement, statistical analysis was still conducted to determine whether these differences were truly significant. So prior to conducting the Wilcoxon sign rank test, a normality test using the Shapiro-Wilk test was performed. The results indicated that the data deviated from a normal distribution. Hence, the Wilcoxon sign rank test was used. And the Wilcoxon sign rank test revealed that there was a statistically significant difference between the learner's pre-test and post-test scores across all indicators. For example, understand the problem improved from a median of 2 to 3.5. Planning problem solving improved from 2.5 to 3. Implementing the plan improved from 2 to 3. Rechecking the solution improved from 2 to 3. All results had p-values lower than 0.05, indicating significant improvement. Therefore, the study rejects the null hypothesis and concludes that problem-based learning significantly improved the learner's problem-solving skills. Based on the findings, problem-based learning proved to be an effective instructional approach for improving grade 9 learners' problem-solving skills in chemistry. And by engaging students in authentic and collaborative learning experiences, PBL encouraged deeper conceptual understanding, active participation, and systemic problem solving. The study therefore recommends the use of PBL in science instruction to help learners become more active, reflective, and skill-oriented learners. Alright, so beyond the statistical findings and conclusions, this study also provided meaningful realizations about the role of teachers as researchers and innovators in education. This classroom-based action research reminded me that research is more than a path toward earning a degree or diploma. It is the active application of knowledge and skills to address the problems that hinder students' optimal learning. The true value of CBAR is realized when it is approached as a genuine effort to improve the current educational situation, driven by care for the future of education and the success of learners. When educators aim to provide better educational services while growing both personally and professionally, CBAR becomes a bridge toward a brighter future. By engaging in CBAR, we refuse to remain ignorant of persisting educational problems. Instead, we commit ourselves to becoming part of the solution and contributing to positive educational change. In many ways, this reflects my teaching philosophy that teaching is the greatest act of optimism, because conducting CBAR means believing that educational challenges can still be addressed and that learners can continuously grow and succeed through meaningful action and reflection. Perhaps in another sense, CBAR can also stand for commitment to betterment through action and reflection. So much for listening, and I hope you learned something from my classroom-based action research. Thank you.
Okay, thank you for that very informative and thought-provoking discussion from Mr. Martinez. Okay, thank you also to all our speakers. I guess we are now ready, or we will now proceed to the question and answer session. So if you have questions, please type them in the chat box or just click the raise hand button. So our question and answer session is 10 minutes only. Sir Bobby, Ma'am Risa, and Sir Einstein, are you ready?
Yes, ma'am.
Okay. So while we are waiting for questions, I just like to say that all three presentations really showed how innovative strategies can truly transform the way we teach and learn chemistry. Okay. So again, if you have questions, feel free to type them in the chat box or click the raise hand button. So your questions might also help others to learn.
I'd like to ask some question. In case of student research here in Mulawarman University, it is kind of rare to do action research because of the limitation of time. Maybe Risa and also Einstein and the other speakers from UNP can share how do you manage the duration of the meeting and then the cycle of the action-based research to make it possible for our student also to do this kind of valuable research.
Okay, thank you, ma'am, for that question. So anyone from our speakers who would like to answer the question? Sir Bobby, Ma'am Risa, and Sir Einstein?
Ma'am Janelle. Good morning, and good morning to. So, with regards with the question, ma'am, how do we manage the duration of the action research to make it feasible for our students? In my case, in my part, the study was carefully scheduled with a regular class timetable. So the different implementation phase was divided into manageable sessions aligned with the learning competencies and weekly lesson plans. Moreover, clear timelines also, specific tasks, monitoring strategies were also established in my case to ensure that these students of mine could complete the research activities, not compromising their academic responsibilities also. And lastly, intervention also was designed to be practical and learner-centered at the same time. So those are the things that I did in order for this research become more feasible in to my students, ma'am.
Okay. Thank you, Sir Bobby, for that. I hope Sir Bobby answered your questions, ma'am. Do we still have any follow-up questions?
Yes, thank you. I think you have some other question on the chat. Maybe shortly, survey we can answer that too. And also Risa.
Yes, ma'am. So we have a question also here. So this is directed to Sir Bobby. Sir Bobby, what specific learning strategies have you identified as effective in helping students understand abstract chemistry concepts such as stoichiometry or chemical bonding? And why are these strategies more effective than conventional methods? So this question is from Sir Rizky. Sir Bobby.
Hello, Ma'am Janelle. Ay, pardon ma'am, will you repeat the question? Hindi ko narinig masyado.
Um, what specific learning strategies have you identified as effective in helping students understand abstract chemistry concepts such as stoichiometry or chemical bonding? Why are these strategies more effective than conventional methods? Sir.
Oh, okay. With that question, ma'am, in relation to my research, since I did a visual representation, molecular modeling on the activity. So using this technique, simulates or helps the students to see atoms, atom bands, molecular structure, specifically for stoichiometry. Visualizing the particles, actual particles, supports them to understand ratios and the conservation of masses. The study also involves also atomic masses. For another one, since it is the intervention is also develops inquiry-based learning, wherein the students may explore or predict products, amounts of bond formation patterns for a good investigation. The different approaches or stations that I have presented a while ago would also help them to focus on balancing equations, molecular concepts, molecular bonding, and etc. So this allows the students to step by step learn that particular concepts. That would be all, ma'am. That's my perception with the question of sir. I don't know,
Sir
sir.
Rizky, from Sir Rizky, sir. Okay, thank you so much, sir. So we also have another question. This is to Ma'am Risa. Okay. I am interested in PHBL implementation in chemistry learning. So what phenomenon that you give to student during the learning? Could you explain it in detail? Is that phenomenon relate in the daily life of students? Ma'am Risa?
Yeah, so I've mentioned earlier that the phenomenon based learning that I've made was anchored to the learning competency, which is describe evidences that the chemical reactions has occurred. And chemical reaction is actually everywhere. It is literally everywhere. And with that, I connected it to a specific phenomenon that I know or that I am aware of that the students also know. Huh? So for the PHBLK1, the specific phenomenon that I used is the changing color or the change in color of the Statue of Liberty. So I think we are all aware that the Statue of Liberty was not originally teal or green in color. It was once a bronze or a bronze in color, but then it transformed into a teal color. So this transformation is actually a product of chemical reaction. So the students were like amazed that this I know that the color of the Statue of Liberty changed from this color to this color, but I did not know that it was due to chemical reaction. So the students were able to identify or able to know that this transformation was all because um, of chemical reaction, which is the main topic of my research. And then for the PHBLK2, it is also connected to real life because it is the formation of soap scums. So are we all aware of soap scums? It's like the white residues in our bathrooms or even when washing the washing dishes or in our tap. There are also soap scums that are being formed, and those are also a product of chemical reactions, which was also new to students. They know that phenomenon, but they don't know that that is a product of a chemical reaction. And for the next kit, which is the phenomenon based learning kit, it is connected to medicines. So it is all about the effervescent tablet. So when dropped into water, it formed bubbles. So the students were also able to determine that not all bubbles are evidences of chemical reaction. So there are a lot of um, ideas or topics that they can learn with this phenomenon based learning, not just the um, topic itself, but also to the other topic, because phenomenon based learning also integrates multiple topics into multiple contexts. And lastly, for the PHBLK4, since most of these students at our university, the laboratory school, are very sporty, so I integrated it the last evidence of chemical reaction, which is the change in temperature, by using the cold pack and hot pack. So they were like, what is they know that the hot pack became I can become cold by shaking it or by breaking it, and the cold pack will become cold by also doing the same thing, but they didn't know that those are also a product of chemical reaction, that those processes are also because of chemical reaction. So they were able to relate those real life experiences, or not, even if not real life, but phenomena that they are aware of, and they were able to explain the process and know the process behind those phenomenon using phenomenon based learning. Also, while learning the main topic, which is the evidences of chemical reactions. I hope that answered your question, ma'am.
Thank you, Ma'am Risa, for that. I hope Ma'am Risa and the other speakers answered your questions clearly. So, do we still have any questions for our speakers? So, I guess no questions na po. So, that concludes our Q&A session. I hope okay. So thank you everyone for your active participation, and of course, thank you to our speakers for your meaningful answers. Okay. Okay, once again, thank you to our speakers for sharing your knowledge and passion, and to all the participants for being part of this meaningful session. I hope you all learned something new and inspiring today. So with that, I guess I will now hand back the floor to our Master of Ceremonies. Thank you and have a great day.
Thank you for the insightful discussion. Thank you to our speakers and moderators. We will now proceed with the certificate awarding for the University of Northern Philippines speakers and moderators. The awarding will be conducted on screen by the head of the Mathematics and Natural Sciences Education Department. To Dr. Abdul Hakim, the time is yours.
I presented this certificate to Bobby and Saint James and Risa. I think good. Thank you.
We will now continue with the session from Mulawarman University. The first topic is designing an educational game based on role-playing game for the subject of algorithms and programming. Now, I will introduce our moderator for today, Arum Sekar Kedaton MPD. Arum Sekar Kedaton MPD is a lecturer in geography education. She holds a master's degree in geography education from University of Yogyakarta and has a strong academic background with a focus on disaster management, environmental studies, and socio-spatial analysis. Her professional experience includes involvement in environmental education programs, climate change research teams, and disaster mitigation studies, particularly related to flood and volcanic hazards. I would like to invite our first moderator from Mulawarman University, Arum Sekar Kedaton MPD. To Ms. Arum Sekar, the session is yours.
Thank you for the Master of Ceremony, distinguished speakers, respected committee members from Mulawarman University, University of Northern Philippines, and all of the participants. Assalamualaikum warahmatullahi wabarakatuh. Warm greetings to everyone. It is my pleasure to be here today. I will be your moderator for this session. In this session, we will have a speaker from Mulawarman University discussing a very interesting and relevant topic related to technology-based learning. Before we begin, let me briefly highlight the theme of the session. Nowadays, integrating technology such as game-based learning into education is becoming increasingly important, especially to enhance student engagement and understanding in complex subjects like programming. So it's really related to our topic for this session, designing an educational game based on role-playing game for the subject of algorithms and programming. So the session will be delivered by multiple speakers. The first one is Ms. Selin Alashima Haris. She is lecturer of computer education, Mulawarman University. She has research interests in the field of information system analysis, educational game-based software and development, and learning media development. And the second one is Mr. Eko Subastian, lecturer of computer education, Mulawarman University. He has research interests in the field of interactive development of learning media and instructional media. And also, Mr. Ahmed Jordi, bachelor's degree at Computer Education Study Program, Mulawarman University. And the last one will be delivered by Putri Nabila Amiruddin, bachelor's degree at Computer Education Study Program, Mulawarman University. So I would like to inform for the participants, if you have any question for the speaker in the session, please kindly take note of them. This question will be addressed during the discussion session at the end of the segment. We kindly ask you to hold your questions until the time. Without further ado, I would like to invite the speakers. The time is yours.
Good afternoon, ladies and gentlemen. I hope everyone have a good condition and thank you for your time to be here. We are truly honored to have such a diverse and accomplished audience gathered here today, united by a shared passion for knowledge and collaboration. Before we begin the presentation, allow me to start by introducing myself. My name is Selin Aloysia Haris, Bachelor of Computer, Master of Computer. I am a lecturer in Computer Education Study Program at Faculty of Teacher Training and Education Mula Warman University, East Kalimantan, Indonesia. Allow me to introduce the dedicated teams behind this research. Here is Dr. Eko Sebastian, Bachelor of Education, Master of Computer, as a lecturer in Computer Education Study Program. Next, there are two students from the Computer Education Study Program, namely Ahmed Jordi and Putri Nabila Amiruddin. Each member has contributed their expertise and energy in preparing the research entitled Designing and Educational Games Based on Role-Playing Games for the Algorithm and Programming subject. We live in the most advanced technological era in human history. Edu-technology in digital era plays a major role in shaping character and developing students' potential. From the statistical data image display by Indonesian Internet Service Providers Association in 2024, the percentage reached 35.97% of Gen Z, aged range 12 years old up to 25 years old in 2024, used the internet to access games, and experienced a percentage decline for the millennial generation, Gen X, baby boomers, and pre-boomers. Online games attract children through visual, themes, graphics, and storylines. As technology develops, more children become addicted to online games. In short, the more appealing a game's theme and storyline, the more fans it gains. An online game is a multiplayer game connected via the internet. As the popularity of online games grow among Gen Z, it's important to consider how these trends can influence educational approaches. Given the popularity of online games, game-based learning can bridge the gap between students' digital preference and learning needs. However, in Journal of Setiawan and Santosa, started the RPG Edu games attract student interest due to engaging audio visuals, motion, and AI. Developing RPG learning games is promising as it combines narrative, exploration, and learning in one interactive platforms. Games can make players feel happy and comfortable, so they are accepted by society. Information technology education plays a strategic role in equipping students with 21st century skills. These skills include programming, data management, and an understanding of information technology. This research problem at Samarinda Junior High School 7th grade, where most students have strong interest in games like Mobile Legends, Free Fire, and open world games. These games such in attracting students' attention with attractive visual, strong narratives, and reward systems. Many students are interested in open world game or exploration. This creates a need for games that combine educational elements such as finding and assembling pieces of learning material. Educational games based on role-playing games are chosen because students not only learn while playing, but also can explore the world within the game, making them more enthusiastic while playing. Educational games based on RPG are designed to provide relevant, flexible, and enjoyable learning experience for students. Teachers must create a learning atmosphere that attracts students, makes technology use and learning interactive. Good interaction between teachers and students in class makes learning easier and more interesting for students, emphasizing the vital role of teachers. Interview with the teachers at 7th grade junior high school revealed that algorithm programming subject is viewed as too difficult for students. An observation with the student, they are lack enthusiasm for ICT lessons, but their interest increases with game-based learning methods. This research aims to develop an RPG-based educational game that helps students grasp algorithm and programming subject while boosting interest in that subject. Additionally, the research assesses the game's feasibility and examines students' satisfaction. In the game, students complete quests, collect educational materials, and acquire simple Python code through challenges, then compile these into a complete set, reinforcing their understanding through interactive play.
In this research, we use the Multimedia Development Lifecycle, or MDLC, as the main development method. As shown in the diagram, MDLC consists of several stages. It starts from the concept stage, where the main idea is defined. Then it moved to the design stage, followed by material collecting, where all need resources are prepared. After that, the process continues to the assembly stage, where the product is developed. Next is the testing stage to ensure everything works properly. Finally, the last stage is distribution, where the final product is delivered to user. In addition to MDLC, this research also used the waterfall model as the software development approach. The waterfall model is a structured and systematic method where each stage is complete step by step in sequence. The process begins with analysis, then continue to design, followed by implementation, testing, and finally maintenance. The first stage is analysis. This stage was conducted at SMP Negeri 7 Samarinda as the research location. In this stage, observation data was collected to understand the need and condition in the field. Now, let me explain the flow of this game system based on the diagram shown on the screen. We can see that the process starts from the player, who enters the main menu. In this menu, there are several options, such as main game, option, credit, and exit. If the player select main game, they will be given two choices, load game or new game. If load game is selected, the system will check whether there is a save file. The player can either continue the game or delete the file. The next stage is implementation, and at this stage, the design that has been prepared in then developed into the real product. In this research, the game is created using RPG Maker MZ version 1.9.0, which is a software specifically designed for developing role and playing games. So, all the elements from the design stage, such as the storyboard, character, and game flow, are implemented into the system at this stage. The next stage is testing. In this stage, testing is conducted to evaluate both the functionality and usability of the system. Functionality testing is used to measure whether the system works according to its intended function. In this research, black box testing is applied focused on the main menu and gameplay. Each part is tested 3 times to ensure that the system runs properly. In addition, this research used ISO 9126 as a standard to evaluate software quality, including its characteristics and performance. Meanwhile, usability testing is conducted to evaluate how easy the system is to use. This test involves both expert and student as respond. The evaluation is carried out using a Likert scale from 1 to 5 to measure use response. This research is conducted on 7th grade student at SMP Negeri 7 Samarinda. The final stage is maintenance. At this stage, the system is monitored and improved after testing. Any problem found, such as bugs or error, are fixed to ensure the system runs properly. To conclude, the explanation of the system development stage is this research, starting from analysis to maintenance. Next, to provide a clear understanding of the result of the game, we will present a demo of the developed game.
Hello everyone, let me introduce myself. So my name is Abhijyoti and it's hard to explain the gameplay flow of the game for Peter Biden. So as you can see on screen, this main page, there are several menus like new game to start the new game, and then load game to play a game that we have already played or a game that we haven't saved. Because in this game, there is an auto-save feature, so we don't need to panic if we are told to go shopping by our parents or spoiled by our mom. And then there is an option menu to set the display, gameplay, and sound. And finally, there is a credit flow. So let's start. So after the new game menu is pressed, we will be directed to choose a character that we can use to play as male or female character. Okay, after we choose, of course, we can use the character that we have chosen, and we will be directly directed to the cutscene. So in this cutscene part, we will be given a choice whether we already know about Python programming or not. So after the cutscene, we will be directed to the backyard of a small village in Palio. So in this game, there are 4 different island world, where every island keep different material with different different levels. And of course, because there is a level system, the enemies will also get stronger on every island. And then we said that to make our character stronger, we said increasing the level and getting some skill, we can also buy equipment like weapons, armor, and jewelry. And we can also buy some potion or elixir to support our character. Directly to the example, here already got one of the piece of the item need to be joined, and the shape will look like this. So which we can see from the game menu in the item pack. Meanwhile, when we get the piece completely joined later, the material will be full of material, and which we can see it from the library menu. Okay, so this is for the example that we have got full of material that we need for the items that we have joined. Yeah, we can see it from the library menu in the game menu. See, as you can see, there's a data type in the description, the string with the description. When we get the material or items, we will be test whether we already know the material or the item we have taken. But we don't need to worry if we don't have time to read it, because before being tested, we will be given a choice like this. Whether we want to read the material or the item or the joint item first or not, we can choose it. Okay, like this. I choose. I'm not already read it with the material. As you can see, the material that we have obtained will be shown up. So for the material piece, we can get them inside the labyrinth or dungeon on every island. After we success doing them, we only need a village place or a big city with a mayor to get permission to the next area. So after we succeed in joining the code, we can try that code by accessing the game menu, then click the code editor menu. Okay, so inside the code editor menu, we can try the code that we have got. So this is like making code inside the code. Like for example, here we try to write an example. The result directly comes up in the bottom box. We say that we can also write anything here, and of course with Python programming code. So if we want to make a list in Python or a library with Python code, or make a game in the game using Python, like for example, maybe a simple Pac-Man game, it's also possible. So, alright, that was the explanation about the main gameplay flow and the player's journey. And next, I return it to the moderator. So,
in this part, I will present the result of the research, which are divided into 3 main parts: functionality, usability, and student responses. First, the functionality result. This research used the black box testing method, which focused on testing whether each feature works properly based on its function. The testing is divided into main menu testing and gameplay testing. As we can see on the screen of my menu testing result, several important users' actions were tested, such as entering the game, pressing the new game button, loading the game, accessing options, and exiting the game. The results show that all features functioned properly as indicated by the valid result in all scenarios. Therefore, it can be concluded that the functionality of the main menu achieved a value of x equals 1, which means all tested functions work perfectly according to expectation. Next is gameplay testing. As we can see on the screen, the testing focuses on several aspects. Based on the results shown in the table, all tested functions are categorized as valid. This means every button and navigation feature works properly according to its intended function. In addition, the gameplay testing obtained a functionality value of x equals 1. This value is higher than 0.5 and very close to 1, indicating that the system has excellent functionality. Therefore, it can be concluded that the educational game, especially in terms of main menu and gameplay, has successfully passed the functionality test. Next is usability test. In this section, usability was assessed from 2 perspectives: validation expert and students. The validation expert consisted of 3 media experts and 1 subject matter expert. The media expert evaluates aspects such as appearance, text, images, technical operation, colors, animation, and audio in the RPG-based educational game.
And based on their evaluation, the media expert gave a score of 73.7%. This result is categorized as very suitable. Next is assessment by the subject matter expert. The assessment focused on curriculum alignment, context accuracy, visuals, and the language used in this educational game. Each component was reviewed to ensure this relevance to the 7th grade algorithms and programming subject. And the final score obtained was 93.3%, which is categorized as very suitable. This indicates that the content of the educational game is accurate, relevant, and appropriate for learning. Next is the result for student satisfaction testing. This test was conducted with 41 students from class 7B at Samarinda Junior High School. As we see on the screen, this test includes various aspects of student responses, each categorized into favorable and unfavorable descriptions. Most aspects are classified as favorable, such as feeling satisfied, interested, challenged, and enjoying the game. This shows that the majority of students had a positive experience while using the educational game. Based on the analysis, the student satisfaction score reached 79.7%, which falls into the satisfied category. And overall, the student responses are dominated by positive feedback, which support the previous result that the game is in the satisfied category. Therefore, the results of both functionality and usability show that this RPG-based educational game performs well, is appropriate for learning, and provides a positive experience for users. Conclusions in the research that the process of developing the RPG-based educational games on algorithm and programming subject has yielded positive results in terms of both functionality and usability testing. In functionality testing, the RPG-based educational game falls into the suitable category, meaning that they have passed the functionality tests. In usability testing, the assessment conducted by 3 media experts and 1 subject matter expert yielded excellent results, placing the RPG-based educational game in the very suitable category. In addition, student satisfaction levels were quite high, placing them in the satisfied category. Student response to the RPG-based educational game was interesting, easy to understand, and helpful in understanding algorithm and programming subject. This is the end of our presentation for today. Thank you to all of you who have listened to our presentation. If you have any questions, please do not hesitate to ask. Thank you very much.
Thank you very much to the speakers for the insightful and engaging presentation. We truly appreciate the valuable knowledge you have shared with us today. With that, I would like to hand over the session back to the Master of Ceremony for the next session. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Thank you to Ms. Arum Sekar. Now, it's time for the second topic from Lawarman University. The second topic is the effects of the STEM SDGs approach on students' scientific skills and learning outcomes in the auxiliary system curriculum at Samarinda Islamic High School, and the effects of problem-based learning with TPACs on students' questioning skills in 11th grade biology at Mandua Samarinda. Now, I will introduce our moderator for today, Atin Nuryadin, PhD. Our moderator is a distinguished lecturer in physics education, holding a PhD, with strong expertise in both scientific research and education. His research interests include functional materials for environmental applications, environmental physics education, and wastewater treatment. I would like to invite our second moderator from Lawarman University, Atin Nuryadin, PhD. To Mr. Atin Nuryadin, PhD, the session is yours.
Well, thank you, Alika. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Welcome to our international webinar. My name is Atin Nuryadin, and I'll be your moderator for this session. Thank you all for joining us. We truly appreciate your time and also your participation in this webinar. Well, now we continue the previous session of speakers from Lawarman University. In this session, we will have 4 speakers which are divided into two interesting topics. Well, it is my pleasure to introduce our first two speakers from the Biology Education Study Program at Mulorman University, Ms. Rukoyah Nasution and Mr. Suparno Putra Makadapi, who are lecturers and also researchers from the Biology Education Study Program. They have published many scientific articles in the field of biology and environmental education. Well, without further ado, I would like to invite Ms. Rukoyah and Mr. Suparno to begin their presentation entitled The Effect of the STEM SDGs Approach on Student Scientific Skills and Learning Outcomes in the Excretory System Curriculum at Samarinda Islamic High School. Ms. Rukoyah and Mr. Suparno, now the time is yours.
Okay, thank you so much, moderator. So today I will explain about the transformation science education. So STEM SDGs integration with the title The Impact of STEM SDGs Approach on Improving Science Skills, Student and Learning Outcome and Excretory System at Islamic High School in Samarinda. So the foundation is education as a catalyst for changes. Why? Because education is one of the most important aspects of human life. To determine their future, education is essential lifelong process personality development. In a school, education is every responsibility, especially in an Indonesian nation. A nation is moral to dedicate development highest quality human resources. Yeah, is it SDGs framework in global version or sustainability development goals? There are 70 targets and 169 goals in 2030. So why the research?
It seems there is problem from the speaker. Ms. Rukoyah, is it okay?
To determine their future, integration SDGs on STEM in the research because the characteristic of biology subject is very challenges. Many students say very struggle to understand the material. One of the example is excretory system. The excretory system is considered complete and complex material in biology. So the excretory system include in curriculum of higher level school in Indonesia. So the concept learned to excretory system include both abstract and complex concept. So STEM SDGs approach can be effective solution for development student scientific skill. This approach provides opportunity for student and learning with a project collaboration and be active involved in learning process. Improving scientific skill, learning outcome, and boost student awareness to importantly reduce environment pollution. Why is this STEM SDGs? Because STEM SDGs is transformative approach. And the STEM SDGs, there are challenges, solutions, science, technology, engineering, and mathematics. And will be related to with the PJPL model. The step for learning PJPL model into STEM SDGs is first asking question, and second analyze. Number 4 is information technology. It's must input to technology, and number 4 is move to explanation in science, and number 5 is obtain to evaluate. The action to evaluate make a conclusion information. Sustainability or sustainable development is crucial for educators have to plan learning and century, because sustainable can be submitted to government and effort to produce quality human process. So the research question is, how does science affect scientific skill and learning outcome and exploratory system? There are two definitions of the research questions. The first, STEM SDGs. STEM SDGs is approach was assessed with the observation and implementation of STEM and classroom regarding to educational system in curriculum and student creative, utilizing links, material, and learning media to support achievement of the SDGs. Number 2 is student-centered skill. Student-centered skill is measured using scientific skill, questionnaire with the Likert scale, and refer to scientific indicators such as observation structure, asking questions and gathering information, reasoning and communicating results. Future education is essential. Okay, thank you so much, Moderator. So today I will explain about the Okay, thank you so much, Moderator. So STEM SDGs integration with the title The Impact of STEM SDGs Approach on Improving Science Skills, Student and Learning Outcome and Exploratory System at Islamic High School in Samarinda. So, the foundation is education as a catalyst for changes. Why? Because education is one of the most important aspects of human life. To determine Okay, thank you so much, Moderator. So today I will explain about the transformation science education. So STEM SDGs integration with the title The Impact of STEM SDGs Approach on Improving Science Skills, Student and Learning Outcome and Exploratory System at Islamic High School in Samarinda. So the foundation is education as a catalyst for changes. Why? Because education is one of the most important aspects of human life. To determine their future, education is essential, lifelong process personality development. In a school, education is every responsibility. Okay, thank you so much, Moderator. So today I will explain about the transformation science education. So STEM SDGs integration with the title The Impact of STEM Project, monitoring and how to check progress and overcomes an obstacle.
Okay, thank you so much, moderator. So today I will explain about the transformation science education. So STEM SDGs integration with the title The Impact of STEM SDGs Approach on Improving Science Skills, Student and Learning Outcome and Excavatory System at Islamic High School in Samarinda. So the foundation is education as a catalyst. The next is teacher must be asking to student about the count and move, urine and test result for demonstration project they made. And the last is teacher evaluate the entry process and result of the demonstration tool project made. The student input the reaction and success for success and obstacle. Yeah, this is a 5 indicator framework in scientific skill will be released to the 15 question in a questionnaire check pre-test and post-test from students. Statistical analysis method using normality and variability to check validity instrument and the t-test to check all the data and the research, and use and gain because the test measure effectiveness learning program and improving student learning outcomes. The method provides a strong foundation to evaluate extent which the learning program and contribute student understand.
Now, let us dive into the core finding of our study, starting with the student scientific skills. Ladies and gentlemen, to measure the impact of the STEM SDGs approach, we assess 5 key indicators of scientific skills. If you look at Table 1, the initial data shows that both group, experimental and control, start at a very similar baseline, with an average score of approximately 50%, placing them in low category. This confirmed that before our intervention, students in both classes faced similar challenges in scientific inquiry. However, after implementing the STEM SDGs approach through project-based learning, we saw a remarkable shift. As shown in Table 2, the experimental group's average scientific skill score rose to 88.78%, placing it in the high category. Beyond skills, we also look at academic mastery and learning outcomes. Moving on to the cognitive achievement, Table 3 illustrates a significant gap in student completeness. In the post-test, 73.08% of students in the experimental class reached the mastery threshold, compared to only 30.77% in control class. Furthermore, our endgain analysis in Table 4 shows that the experimental group achieved a higher gain score of 0.66 than the control group, 0.56. Our statistical analysis, the independent sample t-test, yield a p-value of 0.000. Since this is well below the 0.05 significance level, we can confidently state that the STEM SDGs approach has a statistically significant positive effect on students' learning outcomes in the excretory system material. The question then arises, why was this approach so effective? Our discussion identifies several key factors. First, the integration of project-based learning allows students to connect abstract biological concepts such as kidney filtration with real-world problems. The most influential component was the engineering aspects. Students were tasked with designing and building prototypes of the excretory system using recycled materials, specifically cardboard and plastic bottles. This aligns with SDG Goal 12, responsible consumption and production. By using used goods, students didn't just learn biology, they developed ecological awareness. They practiced the 3 Rs: reduce, reuse, recycle, while simultaneously mastering the mechanical function of the human body. This contextual and hands-on experience turned passive learning into active innovation, which explain the high score in reasoning and communication. Okay, to conclude our presentation, we have reached two major conclusions. First, the STEM SDGs approach is highly effective in improving both scientific skills and learning outcomes for high school students. It bridges the gaps between theoretical science and practical sustainable solutions. We see that the t-test results show a significant two-tailed value, indicating that this approach is effective to improve student abilities to observe, ask questions, gather information, reason, and communicate scientifically. And then, students who engage in STEM SDGs learning show greater conceptual understanding and higher academic achievement than those in conventional learning. These findings confirm that project-based learning that integrates global sustainability issues can more meaningfully encourage the development of 21st century skills. We believe that for subjects perceived as a complex, like the excretory system, moving away from conventional methods toward an integrative STEM SDGs approach is no longer just an option. It is a necessity for modern science education. Thank you for your attention. I am now open to any question or insight you may have. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh. Thank you. Terima kasih.
Well, thank you, Ms. Rokoya and Mr. Suparno, for your excellent presentation. The study showed that STEM SDGs has positive effects on student scientific skills and also learning outcomes. But before we continue to the next topic, I want to sincerely apologize for the issues with the video earlier that was entirely on our end, and I am sorry for the disruption it caused. But let's move on. We will now continue to the last topic. Our next speakers are Ms. Masita and Ms. Nelda Anastasia Serena from the Biology Education Study Program at Mulorman University. They are both actively engaged as lecturers and also researchers. Their work has contributed to a number of scientific publications in the field of biology and environmental education. Today, they are about to present their study about the effect of problem-based learning with TPEC on student questioning skills in 11th grade biology at MAN2 Samarinda. In this case, is an Islamic schools in Samarinda, Indonesia. Well, Ms. Masita and Ms. Nelda, the stage is yours.
Okay, thank you, Mr. Atit. I will share screen now.
Okay, thank you, Mr. Atin.
I'll present our presentation today. Good morning, distinguished scholars, respected colleagues, and honored participants. It is a privilege to present our study entitled The Effect of Problem-Based Learning with the Impact on Students' Questioning Skill in the 11th Grade Biology at MAN2 Samarinda. Presented by me, Dr. Masita, and also my partner, Nelda Anastasia Serena. Today, I will walk you through the background, the conceptual framework, and the methodology of this study before moving into the findings. In this study, we focus on critical issues in science education, namely student questioning skill. Questioning is not just about asking, but it reflects how students think, how deeply they understand, and how actively they engage in learning. Therefore, improving questioning skills become a key indicator of meaningful learning. Now let's look at the problem. In many classrooms, students tend to be passive. They rarely ask questions, and when they do, the questions are often low level. This leads to one-way communication, low engagement, and limited critical thinking. So, the issue here is not only participation, but also the quality thinking behind student interaction. To address this issue, we integrated two important approaches, problem-based learning and TPAC, technological pedagogical content knowledge. Problem-based learning encourages students to explore real-world problems, while TPAC ensures that technology is used meaningfully and pedagogically. So, when these two are combined, they create a learning environment that is interactive, inquiry-driven, and cognitively engaging. And this is where begin to develop naturally. The objective of this study is quite straightforward. We aim to examine whether the integration of PBL and TPAC significantly improve students' questioning skills. More specifically, we want to see not just if students ask more questions, but whether they ask better questions. Now let's look at the relationship between PBL, TPAC, and outcomes. We have PBL and TPAC as the independent variables and questioning skills as the dependent variables. Conceptually, PBL stimulates inquiry, TPAC enhances instructional delivery, and together they create what we call a synergetic effect on student questioning ability. Moving into the methodology, this study used a quasi-experimental design. We compared two groups, an experimental group and a control group. The experimental group receives PBL integrated with TPAC, while the control group used conventional learning. This design allows us to examine the effect of treatment in a structured way. The procedure consists of 3 stages. First, pretest to measure initial questioning skill, and the second is treatment, where PBL and TPAC are implemented, and the last is post-test. This is the final assessment. To measure improvement, this structure helps us to track how student questioning skills evolve over time. Next, for the data collection, we use three main methods. First, observation to capture real classroom behavior. Second, interview uh, to understand perspective and experience for students. And the third, assessment section to objectively measure the quality of question. By combining these methods, we ensure that our data is both comprehensive and reliable. So, having established the methodology, we will now move to the statistical test and the key findings of the study. The next slide will be explained by Ms. Nelda. Please, Ms. Nelda.
Thank you, Dr. Masita. Next is the statistical test. In this section, I will explain the statistical test used. The analysis was conducted sequentially to ensure the validity of the research results. First, a normality test was performed to determine whether the data are normally distributed. This is important for selecting the appropriate type of follow-up test. Second, a homogeneity of variant test was conducted to ensure that the variance between the experimental and control groups are all comparable. Once these two prerequisites are made, the man-Whitney test is used. This test was chosen because the data does not meet the assumption of parametric tests. The goal is to determine whether there is a significant difference between the two groups. Next is the research finding. The results of the man-Whitney test show a p-value of 0.015. This value is less than 0.05. This means that the H0 is rejected. There is a significant difference between the experimental and control groups. These findings indicate that the implementation of PBL integrated with TPEC has a positive effect on students' questioning skills. Next is the student test scores. When we look at the test scores, the experimental group show a more significant improvement from the pre-test to the post-test compared to the control group. In addition, the highest post-test score in the experimental class was also higher. This indicates that the PBL TPEC intervention is effective, improving students' performance, particularly in their ability to ask questions. Next, the proportion of question types. An analysis of question types show a higher proportion of open-ended questions in the experimental group. The data in the diagram indicates that approximately 76.2% are open-ended, while the proportion of closed-ended questions is significantly lower. This is important because open-ended questions are directly linked to higher order thinking skills. Thus, PBL encourages students to ask deeper, more analytical questions. The next slide is the effect of PBL and TPECs. From the PBL perspective, there are three main impacts. First, students ask questions more actively. Second, students develop critical thinking skills through real-world problems. Third, their curiosity increases. From the TPEC perspective, technology helps make this process more effective. Technology supports the implementation of PBL and improves the quality of students' questions. Thus, it is not just the method, but also the integration of technology that enhance the outcomes. And our conclusion is there are two main conclusions. First, PBL has been shown to have a significant impact on students' questioning skills. Second, TPAC serves as a catalyst in the implementation of PBL. The combination of the two results in a tangible improvement in the quality of students' questions. This demonstrates that appropriate instructional design can have a direct impact on students' thinking skills. Thank you, everyone. That's all our presentation. We hope this study will make a significant contribution to classroom teaching practices and teacher professional development.
Thank you so much, everyone.
Okay, thank you, Ms. Masita and Ms. Nilda, for your sharing valuable insights with us. We will now move to the Q&A session. Okay, in this session, maybe we'll have 2 questions. If you would like to ask question, please directly use raise hand feature on Zoom if you want to ask the speaker directly, or you can use chat box to type your question and I'll read it for you later. Okay, any question? We have hand raised from Karinda Cynthia Ranita. Please go ahead. You may unmute your microphone and ask your question directly.
Okay, thank you for the chance. I would like to ask to Ms. Sen Alusima Haris. So here's my question: what criteria were used to determine that MDLC was the most suitable multimedia development method for this research? Thank you.
Okay, I would like to invite Ms. Celine to answer the question.
Okay, thank you. Okay, good afternoon. Thank you for the question of Karinda. About MDLC, right? The MDLC it's selected because especially in design of multimedia development, it's aligned to nature research, creating an educational game. Maybe the step by step from the first, the first is content planning, visual design, and asset collection, and especially in development games in asset design in this game, like actor, like coding, and then the maps can be chosen by the student. And then the next step is development, and then the testing. Now the testing, it's usability and functionality. At MDLC, it's really relevant, and comprehensive framework for its development, especially in game development based educational. Thank you.
Thank you, Ms. Celine. Ms. Karinda, do you have any follow-up question for Ms. Celine? Is it
Enough,
enough?
sir.
Enough, okay, thank you.
Thank you, Miss.
Okay, thank you. Now,
Mr. Atin, you're mute.
okay, now I would like to take a question from the chat box from Ms. Ratapak Wilayrot. I would like to ask Dr. Eko and Putri Nabila a question. For Dr. Eko, in your presentation, you explained that the research used ISO 9126 for software quality testing. I would like to ask, why did you choose this ISO instead of newer software quality standard, such as ISO 25010? And were there any particular considerations regarding the relevance of each indicators for educational games? And the second question for Putri Nabila, in your presentation during the functionality testing section, it was explained that the testing was conducted 3 times and all results were valid. I would like to ask, what was the methodological reason for choosing 3 testing iterations? And do you believe that number is sufficient to represent the reliability of the system? I would like to invite Putri Nabila maybe first to answer the question.
Sure, thank you so much. But first, am I audible?
Yes.
Yes. Okay. Thank you so much for the questions. And first, I would like to answer the two questions because Mr. Eko is not in here, particularly for this time. And the first question is, why did we choose to use ISO 9126 instead of ISO 25010? Because it's the newest. For this, we choose ISO 9126 is because it's still widely used in educational software and game-based learning research, and especially for evaluating functionality and usability and efficiency too, and of course for reliability too. And in this study, the focus was on the testing whether the educational game was feasible, functional, and easy for student to use. And then although ISO 25010 is newer standard and provides more detailed characteristics for the test, but ISO 9126 was considered more suitable for us because its indicators are simpler, easier to implement, and it's more relevant for the studies and research. And since the main objective was to ensure that student could use the game easily and that all feature is properly functions. And in addition, many previous educational game studies use this ISO too. And the second is, why was the functionality testing conducted 3 times? And is it sufficient or to present system reliability? I'm sorry. And the functionality testing was conducted 3 times to ensure consistency and stability of the system result. Repeated testing helps verify that is the features works properly or not, and not only once, but constantly under repeated usage conditions. And then the 3 irritation were considered sufficient because the system produced the same valid reason in every test without errors and functions very well, and there's no functional failures. Since the research is focused on product feasibility testing rather than large-scale industrial software reliability testing, the 3 repetitions were adequate to represent the stability of the educational game functions. And however, in the future, maybe the development will be used the newest ISO to test the functionality of the game. Thanks for me. Thank you, and I'll give it back.
Thank you for Putri Nabila for the informative answer. I think it's enough answer the question from Miss Ratapak. Okay. I would like to, maybe we have one more question for biology education. It is from Miss Dora. I would like to ask Dr. Masita and Miss Nelda. My question is, how adaptable this learning approach for digital or hybrid learning? Okay, would you like to answer this, Miss Masita or Miss Nelda?
Okay, thank you, Mr. Atin, and thank you, Ms. Dora, for the question. Technology integration is already central. The model expressly combines digital tools, real pedagogy, and biology content. The article explained the TPEC was used to integrate technology, pedagogy, and content in modern learning. This means the transition to hybrid or online setting would not require redesigning the core approach. Teachers can replace face-to-face interaction with LMS platform like Google Classroom or Moodle, discussion forum, collaborative documents, and many else. PBL fits asynchronous and synchronous learning. PBL relies on inquiry, discussion, and collaborative of problem solving. This process works well in live online meeting, hybrid classroom discussion, independent and synchronous investigation. And the third, maybe the model promotes active participation online. The study found that students in the experimental class produce more question, more period question, higher analytical questioning levels compared to the control class. Thank you, Mr. Atin.
Well, thank you, Ms. Masita and Ms. Nalda. I think this is the last question. Thank you to everyone who asked question and contributed to the discussion. This brings us to the end of our Q&A session. Thank you to our speakers and also all participants for the engaging session. We hope you found this webinar informative and valuable. Have a great day. Assalamualaikum warahmatullahi wabarakatuh. Now I'll turn it back over to the MC, Alika. Thank you very much.
Thank you to our speakers and moderators. Thank you for the productive discussion. We will now proceed with the certificate awarding for Mula Warman University speakers and moderators. The awarding will be conducted on screen by the head of the Mathematics and Natural Sciences Education Department. To Dr. Abdul Hakim, the time is yours.
Thank you. I would like to say thank you to the speakers. I am presenting the certificate virtually to Dedin, to Eko, Ahmad, Putri Nabila. I think that's all. I am presenting the certificate virtually to Rukaya, Suparno, Masita, and Nelda. I think that's all.
Thank you. Congratulations to all our speakers and moderators. All participants are kindly requested to fill in the attendance link displayed on screen or by scanning the barcode. To all participants, you will receive your certificate through email around 7 days from today. Thank you. Distinguished guests and participants, we have reached the end of the International Webinar 2026 Series 2. We would like to express our sincere gratitude to all speakers, moderators, and participants for your valuable contributions. May the knowledge gained today inspire innovative practices in science teaching. On behalf of the organizing committee, I apologize for any shortcomings during the event. Thank you for your participation. See you at the next webinar. Good afternoon and stay healthy, everyone. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.